Good morning, everyone. This is Carl Griffith from Graybar, and I would like to thank you for attending our G2 Talk webinar this morning, where we're going to talk about finding a cure for network capacity pain, primarily in hospitals. Excuse our pun there, but it was kind of fun to write that title. But we do have capacity pain in our networks when we talk about how data is transmitted in a healthcare facility, whether it be Wi-Fi is where that data moves around, or whether it be in a cellular capacity, it may move around, or whether it's with wired ports in your facility. This data is moving around, and there is convergence occurring, and we're going to talk about that a little bit today and see if it can simplify our lives, particularly in the healthcare space. Before we get to the subject at hand, I wanted to give you a little bit of information about Graybar and what Graybar is all about. Graybar is a distributor of electrical and communications products, and we have the following brand statement, that Graybar helps our customers power, network, and secure their facilities with speed, intelligence, and efficiency. And that's what we will talk about today. We'll talk about that network, and we'll talk about speed, intelligence, and efficiency as it applies to the network. And the facility today is primarily in the healthcare space. Before we get started, I wanted to give you a few reminders. Number one, everything you see today and hear today will be archived. You can go to graybar.com, click on the G2 Talk webinar logo. You'll see an archive button there. If you click on it, you can go back and get the information, both audio and the printed portions of the presentation today, as well as some other handy tools to help you in terms of white papers, etc., available to you to look at your leisure. The other thing I wanted to remind you is that there's a Q&A. So you'll notice at the bottom of your screen you have a little Q&A button, and if you click on that, a dialog box will open, and that'll give you the opportunity to type in a question. At the appropriate time in our webinar today, we will respond to those questions, as many of them as we can. So anytime you have a question, open the dialog box up by hitting the Q&A button and give us the question, and we'll get it on our end, and then we'll respond to it in a little bit. If you're one of the fortunate people to be the first 50 people online with us today, and you remain with us on the webinar, we will send you a certificate for a cup of coffee from a major coffee company in the United States, so you can take that webinar and take it to their counter and exchange it for a cup of coffee, and we're just glad to offer that to you today. So without any further delays, I'd like to introduce our speaker today, and our speaker is Stephen Cook from Corning. He's the Regional Wireless Account Manager for Corning, and the Corning solution we're going to talk about today is the Corning One platform. Stephen has 20 years of experience or more in the industry. Prior to joining Corning, he worked with Sprint in their distributed antenna system and mobility practice at Sprint. What's interesting about Stephen and his relationship with Sprint is that there are several people at Graybar who worked at Sprint that are part of our distributed antenna and mobility practice here at Graybar as well. So this is kind of like old home week. So without passing any more time and give the baton to Stephen, I'd like to let Stephen talk to us a little bit today about our networks in the healthcare space. Stephen, it's your turn.
Thank you, Carl, for the introduction, and good morning to everyone. So as Carl mentioned, I'm the Regional Wireless Account Manager for Corning, and I am focused with my role on enterprise customers and that are interested in really rolling out a distributed antenna system and other like applications within their infrastructure. We're going to talk this morning a little bit about the pain points and some of the things that they're experiencing in the healthcare vertical, and how the Corning solution can really be a part of allowing them to converge multiple infrastructures together. First, I'm going to tell you a little bit about Corning this morning and about our company. And if you look here, Corning, most people think of Corning as the company that made kitchenware. And while we used to make kitchenware, we're really more than that. We're really a technology company. We're a worldwide company that specializes in technology around glass and ceramics. We've been around for over 100 years, and worldwide we employ over 30,000 people. Looking at some of the different segments that Corning has within their business, we're involved in the display technology business. So many of your LCD and LED TVs, the displays that are part of those devices are actually made by Corning. The optical communications branch, which makes fiber optic cabling, connectors, accessories, is also the branch that the distributed antenna systems falls under. We're also involved in many environmental technologies and products. We make the substrates that go into catalytic converters that control pollution. Also involved in life sciences. We develop glassware and other materials that are used in the life sciences industry for both healthcare and chemistry, other things in that product line, microbiology, for example. Also involved special materials, the things that make up a device that you probably have in your hand today or nearby. Corning Gorilla Glass is used in smartphones and tablets, as well as we make materials that go into semiconductors and optics that are used in the aerospace and defense industry. And then last but not least, we're also involved with some other third-party companies that we either have partnerships with or own a share of, companies like Dow Corning and Samsung Corning Advanced Glass. So a little bit about Corning and our history and things that we do. We're going to talk to you today about something called the One Platform, and really how the One Platform that Corning has developed can be really part of a converged solution, specifically around healthcare. So the first thing we'll talk about today is really, looking at the healthcare space. One of the biggest challenges they're facing today is really keeping up with the technology at hand and keeping up with the devices and applications. In a healthcare type of environment, you see doctors and other people today, including patients, patient representatives, nurses, using wireless devices within that enterprise environment. It can be devices anything from an iPad to a smartphone to a wireless laptop or other device that's taking patient information. And that's creating quite a challenge for healthcare institutions as they try to keep up with the number of devices and actual software apps that are being used on them. That is leading to things like congestion in their network, congestion where it's requiring additional hardware to support these devices and applications. Their closets are getting crowded with additional hardware. And along with that, the ever-changing cabling infrastructure that's needed to really allow the bandwidth and allow that information to flow back and forth. So we've talked to healthcare IT professionals, and these are the key things that they see as being a challenge today within their environment. So if we look at enterprise networks in general, and not just healthcare, enterprise networks today are really at a point where they're saturated from a bandwidth capacity perspective. The technology and the applications are certainly outgrowing today's business needs, and they're outgrowing them very quickly. If you look at some of these numbers here that we've kind of brought together from independent resources, by the year 2015, 80% of the wireless LANs will be obsolete. They will need to be upgraded, infrastructure replaced, complete gutting jobs needing to be done. Also looking at, enemies from within. Big challenges that both healthcare and enterprise institutions face today is BYOD, which is bring your own device. Whereas they're having to control access to those devices, not having enough control where those devices are accessing resources on their network, things like, social media applications. Increasing reliance on the cloud for storage, where that cloud storage, where you're sending that information back and forth, is again increasing the bandwidth needs on their networks. Talk about user experiences for a second. In a healthcare environment specifically, medical imaging, patient webinars for health purposes, all those things being transported across their network inside their facility requires strong quality of service. And again, those bandwidth requirements are adding to the pain points. And the biggest thing here that is of interest to them right now is how do we drive down costs? How do we reduce Capex and Opex? We do this by, hopefully having some kind of convergence, and they're also looking at green buildings today. And again, if you look at the statistics down at the bottom of the slide, by 2017, over 63% of the workloads will be cloud-based. There's some big numbers. So we're really, the last probably 2 years that I've been with Corning, we've been out there really evangelizing the fact that a shift in thinking has to take place about how customers, and not just healthcare, but enterprise in general, think about how they align their network characteristics with the business needs today. If you look at this slide, you're probably seeing some of the same things happening in your environment or in a healthcare environment. But again, mobile is the norm of user access now. Most enterprise customers, healthcare included, their devices today, the smartphones, the tablets, are really becoming business tools that have to work and have to work well. No longer are people tied to a desktop phone, and they're roaming around using these mobile devices as their main form of communication. Green technology. Any new buildings that are going up today, any renovations that are happening, green is one of the buzzwords today in the building industry. And green operations, they're being used, green technology is being used to reduce energy footprints, lower OPEX costs. Customers are looking for lead credits, and they're looking for ways to become just more environmentally friendly, building. Again, we talked about this in the previous slide. So cloud being the norm of back access. Again, as we see more and more applications that may have been on a server before or on a desktop being moved to the cloud, again, increasing bandwidth needs. Agile business cycles. We see customers constantly changing the way they do business. They may be in a building today, moving to another building tomorrow, adding floors to a building. Moves, adds, and changes are happening quicker than ever before. And then the last piece here, increasing the network density while driving down costs. So, co-deploying network infrastructure that can support multiple applications. Building management services, it could be surveillance, Wi-Fi, security, any of those things. They're trying to look and find ways to really bring these services together over one platform. So the solution that we're going to talk about today is really the Corning One platform. Corning developed this solution based upon the needs of enterprise customers that we've spoken to. And the Corning One solution is really a platform that allows the convergence of different applications across the same fiber optic cabling backbone. Immediate solutions that it can provide today could be passive optical LAN, Wi-Fi networking, cellular service today on a DAS, and then down the road more applications. Additionally, as you look at the different applications that can be brought together in this platform, the savings that can happen definitely increase as you add more applications to the solution. We see customers today, looking at PON as a way to really rationalize their costs and bring together things like building management services, HVAC monitoring controls, lighting monitoring controls, fire and security. Corning is even looking at partnering with companies like Honeywell and Johnson Controls to actually bring together these services as one solution. So let's talk about how passive optical LAN and DAS deliver on the value of assured fiber infrastructure together. So we'll first talk about the passive optical LAN piece. So if you look at the network services on the left-hand side of the slide here, you'll see the different things that most customers today have in their environment. They probably still have some analog voice services going on, obviously some packet voice, their IP and Ethernet network, perhaps video network. That's certainly something that you're going to find in a healthcare environment. You could have RF video involved, bringing in that RF to the rooms, patient rooms, etc. A passive optical LAN infrastructure today can really provide the backbone to do all of those applications today. It allows you to connect your desktop computers, your analog or VoIP phones. It allows you to connect Wi-Fi access points, building management services, obviously surveillance cameras, video conferencing, RF and IP video, and then smartphones and beyond. The DAS piece of it can be kind of really just overlaid over that existing PON infrastructure. PON can be done first. The one DAS system could be done first. Either way, the two work hand in hand with each other. They use the same fiber optic backbone or infrastructure to provide those services. When you do them together, you really create a positive total cost of ownership that helps pay for the DAS infrastructure. The DAS part of it here can leverage that existing cabling infrastructure that's going to give you that reduced Capex. When you share the fiber infrastructure, the DAS is running on separate fibers within that same fiber backbone. We have customers asking about this solution today, and we've seen definitely an uptick in the last several months where its interest is really starting to peak at the highest levels probably in 2 years. This network can support both public and private Wi-Fi access points. And again, there's also synergies with combining the fiber management and power and backup solutions with these two types of services. PON provides a deep savings from an energy consumption perspective because you're taking out of the closet those switches that typically require power, maybe cooling in the closet. The same thing for the DAS infrastructure. The DAS infrastructure as well is very simple and does not draw a lot of power as traditional DAS has in the past. I'm going to talk about just the PON technology for a second and just kind of explain what it is. Some of the folks on the phone may not be familiar with it. But passive optical LAN is based on gigabit passive optical networking, GPON. And it's a technology that's been out there and about for many years now. It was first rolled out, and many of you are probably familiar with it as Verizon Fios. Verizon Fios is basically passive optical LAN, fiber to the home. The technology has been around for over 20 years and works very well. The technology is now being really rolled out to fiber to the port. So now you're taking that same infrastructure instead of fiber to the home, but you're bringing it to every port in the network. So the standards for PON were really developed from the International Telecom Union, and it's based upon the actual standards you see below. I'm not going to get into those in much detail, but in a PON network, you have an upstream and a downstream flow of data going on. It's a proven technology. It's been used worldwide. It's a future-proof infrastructure because the single-mode fiber that's involved with PON effectively really doesn't have a bandwidth limitation today. The bandwidth is only limited by the hardware that's connected to it. Because it is fiber, fiber can last a long time. Single-mode fiber that is in use today that maybe was installed 20 years ago is still working fine. And the average, life cycle of single-mode fiber, you're talking 25 years to 30 years. It's also very easy to manage. There's two key pieces or parts of hardware that are involved in a PON network. You have the OLT, which is the optical line terminal, and the ONT, which is the optical network terminal. The optical line terminal is really the head end or we'll say the control system or the brains of the network. The OLT is a device that sits in a rack typically in a telco room and is connected to the customer's core switch. That optical line terminal then provides connectivity out to all the different ports in the network. At the other end, where the port's going to be, we're going to use an ONT, an optical network terminal, to provide that endpoint connectivity. The ONTs provide that RJ45 jack that allows you to plug in your traditional, we'll call it the IP type device, with a piece of Cat5 or Cat6 jumper cabling. As we get a little bit more into this, you can see in this slide now, On the left-hand side, you have your services here. We have voice, data, video, maybe analog video, hitting our PON head end, the OLT. And from the OLT, a single OLT card in there today can support 2.4 gigabytes of download traffic and 1.2 gigabytes of bandwidth coming up. The manufacturers today really involved in PON, the main ones are Zone, Z-H-O-N-E, and a company by the name of Tel Labs. And both those companies are looking at developing and rolling out we'll call it a higher bandwidth card later this year. The card is looking to come out later this year, can support up to 10 gigabytes of traffic download now. So a significant increase from where we're at today. Out of each OLT card, a piece of single mode fiber is then split up to 32 ways. We're using a passive splitter here, and you can see that in the picture. This picture is really showing you a three-way split, but that splitter can split that single piece of single mode fiber up to 32 ways. And that piece of fiber now that's been split is sent out to an ONT. The ONT is a piece of hardware, again, that can be incorporated into a wall jack where you'd never know the difference. It would look like a normal wall jack where you'd plug in a computer cable. It can be an ONT that has wireless LAN capabilities for a Wi-Fi network. Or it can just be a simple ONT like we have in the right-hand corner where there's several ports on it. The ONT, again, provides that endpoint connectivity and takes the encrypted information coming through the fiber optic cabling and sends it to the correct port on the network. There is two different streams in that PON network. You have an upload stream and a download stream, and they run independently of each other on that same piece of single mode fiber. The technology that is used to support that is WDM, and that's wave division multiplexing, and basically breaks down that information into little chunks of time and sends the information separately in those little chunks of time. So the key advantages here for a PON network and why it's a key part of the one solution, total cost of ownership, it's obviously lower because you're leveraging less actual hardware, less cabling costs. From a green perspective, by limiting those switches in the closet and less equipment, you're using less power, which requires less cooling. So it certainly is a environmentally friendly solution. Its high availability and security makes it also very valuable to folks, especially in the healthcare industry, because the information is broken down in those chunks of time. It's very secure, and PON is even being used today by government facilities in the military. And then the last point here, from a future-proof infrastructure standpoint, again, as we look at single mode fiber as the backbone of the solution, the single mode fiber certainly has a life of 25 to 30 years. So again, talk about the converged solution here. The converged solutions out there certainly enable Capex and Opex savings. And the big key points that we try to drive through with customers that we talk to is that from a moves, adds, and changes perspective, there's probably a 20 to 35% savings here. There's much faster deployment doing a fiber network with both DAS and PON, and much simpler to move things around, make changes for customers as their needs change. In terms of materials and the weight and the size of those materials, there's a 30 to 40% savings there. If you look at the cost of fiber optic cabling today, it's significantly lower than it used to be years ago. And combine that with the cost of copper and the weight of copper cabling today, significant savings to be had there. There's labor savings. There's no multiple cables to pull to deploy a solution. The pathways aren't clogged like they used to be with hundreds of Cat 5, Cat 6 runs being done. The fiber optic cabling is also, from a weight perspective, very light in those pathways that may sit above ceilings. And the last piece here, really from a maintenance perspective, PON networks are easier to maintain. There's less electronic pieces to go bad, less maintenance that needs to be done. I'm going to go through just a typical network installation for you here on the slide and talk about, again, how it's been done in the past. This slide is depicting, a traditional solution here where we've used category cabling to provide the LAN connectivity, and we're using coax to provide the connectivity for the DAS. And you'll see here the coax is represented by the green color, and the blue is representing our category cabling. And this is the way it's traditionally always been done. Two separate infrastructures that have been laid out here to provide the necessary services for a customer's environment. If you look at this, and we look at this on a floor plan, this is a floor plan for a building that's approximately 400,000 square feet. And this is just one floor of the building that's depicted here. But in that entire build, you'll see that to do what we need to accomplish with the coax and category cabling, we had to run over 15,000 feet of coax for the DAS network, 180,000 feet of category cabling for the LAN network, at a total weight of 5,500 pounds. So think about the labor involved to deploy that. Think about the weight and the cost involved for all that copper. All right, so we're going to talk about it now from a different perspective. We're going to look at this from the perspective of using the One Wireless platform, incorporating PON into the picture as a different way to deploy the same solution, but in a similar format and a similar floor plan. So in this picture here, you'll see that we still have fiber running from our MDF to our IDF. But coming out of our IDF now, we're using a piece of Actify cable that Corning makes. It's a piece of cable that incorporates copper cabling and fiber together to provide the connectivity out to the endpoint, either the ONT or something we call the remote access unit within our One DAS platform. And that Actified cabling picks up power in the IDF from a 1U rack unit piece of equipment we have that acts as a low voltage DC power supply. In that IDF, we also bring together the PON network cabling and the DAS fiber. They run independently of each other, and it is run using one piece of cabling, so you have different fiber pairs running in the same cabling sheath. And that runs out to the endpoint here. So if you look at the middle here, the big convergence piece or the savings piece here is really in the space and time. If you can see their typical installation time, and space, the one solution is really half the time and half the space of the typical, copper solution. As we look at this again, deployed on our floor plan here, that same 400,000 square foot building, again, this is one floor of the building. We're using that one piece of Actified cable to get out into the horizontal environment. And for there, we're using our ONTs for the ports on the network. The Wi-Fi access points are connected to the ONTs. We're deploying our RUs, our remote access units, as the DAS antennas. And in this example, we're using only 7,000 feet of that composite fiber, 30,000 feet of fiber total, at a weight of 700 pounds. So there's certainly savings to be had here, less cabling to be run, there's less weight up there, the cost of the cabling is less expensive because we're not using copper, and the installation is easier and probably takes about half the time. All right, I want to talk for a second now about a real use case in the healthcare environment for cellular and passive optical LAN convergence. So this is a use case. This is a customer of Corning's that we have today. It's Guthrie Hospital. Guthrie Hospital is a healthcare system that was developing a brand new hospital building to be built, a state-of-the-art facility in Corning, New York. And they were building this property from the ground up. Guthrie Hospital made an active decision and selected PON as the technology for their LAN network. So that was decided before we were even involved with the DAS. They used the PON network to serve Wi-Fi, nurses stations, RFID, and many of the other IP services in the hospital. But like most customers, as they got done with their building and completed it and opened it for business, they realized they had a coverage issue inside. Being state-of-the-art, the building was also built with very green technologies. And it was built to provide energy savings for the facility. So immediately they recognized that they had an issue with cellular coverage. Many of the patients, doctors, and other key personnel did not have coverage within inside the building to make a phone call. They looked at several different solutions for the DAS. They looked at traditional DAS solutions running a completely separate, we'll call it coax fiber hybrid DAS system. But when we looked at this with one of our integrators and asked a few more questions about their existing environment, once we determined there was PON involved, we were able to really determine if they had additional fiber available to help with the DAS project. We learned that the customer had the intelligence up front to install additional pairs of dark single mode fiber throughout the building. They used a zone-like architecture and used zone boxes. They have over 100 of them deployed throughout the facility. And these zone boxes, which are installed in the ceiling, house the endpoint for their ONTs of their PON network. They have additional strands of fiber. I believe there's 12 single mode strands of fiber running to each zone box that are dark today, and that was left there for future growth or other projects or applications maybe that would come down the road. So as we looked at this project, all we really needed to do to deploy the DAS here was to provide the head-end equipment in the telco room, connect that to their existing fiber being run to the zone boxes, and then deploy our antennas based upon our RF design and connect those to the zone boxes within the ceiling that were already in place. It really allowed us to do the complete DAS for them, getting a 30% savings over traditional DAS because nothing had to be done with the cabling infrastructure for the DAS. It was already in place. So look at this next slide. I'm going to go a little bit more into detail about the actual design itself. Again, if you look at the left-hand side of the slide, you'll see that there is a PON OLT, or the head end for the PON network. You have the Corning 1 DAS head end there. And coming out of each of those two products would be single mode fiber that is then brought together in an actual fiber management unit that sits in the telco room. From there, that fiber is being distributed to IDFs within the facility, where they're utilizing the PON splitters. The PON splitters are, again, passive devices. It's just taking that one piece of single mode fiber now coming from the OLT and using a mirror to splitting that light beam into 32 different strands of fiber. Those strands of fiber, again, are being sent out through the ceiling to the zone boxes where the ONTs are placed. And from there, the ONTs are providing the connectivity for the end devices, whether it's a wireless access point, a port for a piece of equipment at a nurse's station, or the telemetry devices for monitoring patients' information, or anything else that might be running off the network. So a single fiber backbone here serving both the DAS and PON network. This is going to just show you on this next slide here just a view of the actual equipment involved. And again, just a different way to look at the architecture layout. But on the left-hand side would be the equipment in the telco room. On the bottom is their core switch. Above that in the middle is the Tel Labs PON head end. And then, of course, the Corning 1 DAS equipment. And again, the fiber coming from each of those pieces of equipment is kind of brought together there into one main fiber bundle, then out through the horizontal, going to a PON splitter depicted there in the middle, by the triangle and the separate strands coming out of it. From there, we're going to an ONT again, which comes in a variety of shapes and sizes. The one we're showing here is one that might sit under a desk at a nurse's station, and then providing the connectivity for both the DAS and those other services you see there. This next picture here just depicts what the ceiling looks like from an environmental perspective. And you can see here we have the green circle showing the Corning 1 REU, our remote access unit, which is our antenna and remote. You have their Wi-Fi access point, and again, their medical telemetry. And again, these devices are all running across the PON network. This next picture is depicting one of their zone boxes. And again, they have over 100 of these deployed throughout the facility. And in this zone box, you'll see that there are 6 ONTs deployed. Each one of these ONTs has 6 ports on it. And from here, they're running traditional Cat5 and Cat6 short runs to their end ports or end devices. They might be going to a jack on a wall. They may be going to a ONT that might be sitting underneath a nurse's station. And this is where we connected our DAS equipment to. When we overlaid our DAS design with where their zone boxes were located, we were probably at the most maybe 5 feet away maximum from each of the zone boxes. And they had those 12 pieces of single mode fiber left dark in each of these zone boxes. We just created a fiber jumper between the zone box and our DAS antenna, and that provided the connectivity for the DAS network. So to sum things up today, the One Network is really a future-ready network that brings together the abilities of converging multiple applications together. Now, it's not just DAS anymore. Customers are looking for ways to really converge all these different IP applications together. As technology continues to change and we become a more internet-connected world, many of the things that we use today will all be IP-based at some point down the road. The One platform really gives you the unlimited bandwidth of fiber to the edge, allowing you to deploy, the most commonly used applications today, like passive optical LAN, Wi-Fi, cellular. It also gives you the ability to do other services later, or maybe even at the same time now. Things like security, HVAC monitoring, power monitoring, lighting monitoring, and other IP applications. Again, the simple thought here is convergence. How do we find ways to lower costs from both Capex and Opex perspective? That really sums up my part of the presentation for today. I appreciate everyone's time this morning. At this point, I'm going to turn this back over to Carl to start the Q&A session.
Thank you very much, Stephen, and I'm just so glad that you were here today to talk to us a little bit about converged networks and how the One solution can help us get things like Wi-Fi and distributed antenna or cellular services or traditional LAN services or medical telemetry or asset management or point of sale and get them all over a converged fiber optic cable network, and then use these zone boxes like you described and other applications as well, other different types of boxes in the hospital to deliver those services. It's just absolutely fantastic what you're describing here. In my conversations with people in the healthcare industry, we've been told that it's very disruptive to recable. That if we have to recable and we have to take out, like, for example, Category 5 cable and reinstall Category 6A cable, all the work that has to be done to close down a wing and seal it up and to get all the things that need to be done to get that whole thing recabled. And it seems to me that this example you showed of Guthrie Hospital, where one cable could be deployed to do all these services rather than wiring up disparate networks all the time, a disparate telemetry network or a disparate cellular network or a disparate Wi-Fi network. We could do this all over a single cable and be less disruptive. It would seem to me that if a healthcare professional in the healthcare industry was recommending to rewire a hospital, this might be a logical way to go. Do you agree with that?
I do, and we have many healthcare clients today that are looking at this solution and looking at it, from a standpoint, from exactly like you just mentioned. Anytime that you have to open ceilings in a healthcare institution or a healthcare environment, it requires a great deal of work, time, and labor tenting, around the areas to prevent infectious disease, things like that. So this is seriously being considered in the healthcare industry, and we're going to, healthcare-focused events around the country and talking about it. And the interest from healthcare in this solution is very high at this time.
Right. Another question here, and I wanted to address it. And I'm gonna go back to your slide number 22 and push it to the audience here. I hope you don't mind. But in the lower right-hand corner, we show one of these zone boxes down there, and I just wanted to point out to the folks that were there is on the lid of that zone box, you can see it hinged right now and hanging down. On the lid of that zone box, you can see what's known as the Corning Mobile One RAU, that remote antenna unit, and that's actually the cellular antenna that allows cell services to be deployed in that particular area of this hospital. Is that correct?
That is correct. And in this example, the box is down. That is one type of zone box, and then on one of the further slides, I think I actually shared with you an actual picture of the zone boxes that they were using in their actual deployment. These zone boxes come in different shapes. Some you can install the DAS antenna in it like this, and that's why that was shown as an example. And then others, you can put the DAS antenna near the zone box and connect it like Guthrie did by just running a fiber jumper over to it.
Yeah, and Stephen, if you don't mind, I'd like to also point out that if we look at this lower right-hand picture that shows that RAU on the lid of that box, that zone box that's in the ceiling at a hospital, inside that RAU with the Corning Mobile One architecture, we can actually have a couple Ethernet ports, I believe up to 4, inside that box, which makes deploying Wi-Fi extremely easy because now we can deploy the cellular network that enables our connectivity to patients and to healthcare professionals that want to attach to networks using traditional cellular carriers, but it also gives us connectivity to a Wi-Fi network that we can use inside the building and for other purposes. So really we have a dual capacity here for mobile connectivity for both cellular and Wi-Fi. And the reason I bring this up is there was a question that came in on the Q&A from Bruno, Joe, and he was asking about how BYOD, how does BYOD fit in the picture in this network that we're describing, and that's part of it right there. All kinds of people come into a hospital with all kinds of different devices, whether they be tablets or whether they be cell phones or whether they be laptops or whatever, all kinds of different brands, all kinds of different things. And this allows patients, healthcare professionals, and others inside the hospital to attach to the appropriate network that they need to attach to with their own device that they bring into the hospital. And it's easy to do it with mobile and cellular and with Wi-Fi. So that's the reason I brought that up. Let me see if we have any other questions in it if you wanted to make a comment about that.
Yeah, absolutely. So, there's different ways to think of convergence with the one platform, and maybe a customer today doesn't want to take advantage of the full convergence that you get with a PON network. And as you mentioned, Carl, that's correct. Each one of these RAUs, you have the ability to provide IP connectivity at these remote access units, 2 ports, 4 ports, and it can be used, for things not just Wi-Fi access points. It could be used for security cameras. It could be used for an HVAC monitoring sensor, and you have the ability to bring just, we'll call it half convergence here, bringing out IP connectivity to that remote access unit, and not incorporating a complete PON solution.
Great. Thank you. Bill asked a question about does Graybar, as a distributor of connectivity gear, are they permitted to sell the Corning active components that are necessary to make this work, as well as the active components for the PON network, which would be The ONT would be an active component in the OLT in the PON network. And I'll go ahead and take that question, and the answer to that is yes. Graybar is the distributor for both Zone and Telabs on the PON side. That gives us the electronic components there for PON connectivity. And I'm sure the person, Bill, that asked this question understands that we have all the passive connectivity as well. And then the other question was about the active Corning One gear, which would be the RAU, the base station, the pieces that you need in order to enable power on the optical cable to get power to the RAU, as well as Ethernet connectivity, et cetera. And we can provide those components as well. So I thank Bill for asking that question, and we can help you out with that. There was a question that about IPv6 and how that affects what's going on. The question had to do about automobiles. I don't quite know the answer to that, the one that Joe asked. I'll get back to you on that. I do know that networking gear, whether it's earlier IP versions or whether it's IPv6, are supported with the PON connectivity that's described on the presentation today, but how it has to work with automobiles, I don't quite understand. So I'll get with you offline on that one, Joe, and we'll see if we can handle that question. There were several questions that came up online about getting copies of this presentation. Can they get some cut sheets on some of the equipment? And I think people are looking for some more detailed information about the architecture. There were several of those questions that came up online, and we will provide that. We will respond to your question offline to get that to you and send you a package, but I wanted to let everybody online know that the information that you received today is archived, so you can go online to graybar.com, click on the G2 logo, and this presentation's up there for you to review any time that you want. And also, there is a case study up there for the healthcare facility that was mentioned in Steve's presentation, and it will be there for you as well. The question from Dennis came in and says, in this scenario, what was the installation time to add that existing equipment that you described in this healthcare facility? Do you know the answer to that, Stephen? Was there? If I understand it correctly, the healthcare facility was built with a PON infrastructure, and because of the design of the building, particularly e-glass and maybe part of the building materials, then the hospital discovered that their cell phone access, their cellular devices were not working properly, and then they had to go back in and then fix the cellular problem they had. If I described that right, and I'd like to know that, and then what kind of time did it take to get that cellular piece installed once the PON network was already installed?
So that's exactly correct. The PON network was already a choice the hospital made for their LAN infrastructure, and that was already rolled out and installed. And, I don't know the exact times of the installation for the DAS network, but I will tell you it was probably, the timelines to do that was probably at least cut in half, probably 50%, just because of the fact that none of that cabling had to be run again out to the point where the antennas were being placed. The antennas, the RAUs, were placed in the ceiling, and from there, again, just a fiber jumper was used between that antenna and that existing zone box in the ceiling. So I would certainly say that time was probably cut in half. It was probably greater than that from an installation perspective.
So the secret sauce here, Steve, if you don't mind me adding to your response there, was the single mode cable was already installed in the ceiling in order to provide the PON, passive optical network, or passive optical LAN, which are both the same thing, to provide that PON network. And then since Corning's RF platform for cellular connectivity uses single mode fiber as opposed to coax, we were able to use fibers that were available inside that fiber sheath and use them for the DAS network as well. That's correct, right?
Absolutely. That's exactly how it was done.
All right. So Eric asks a question here. This cellular solution appears to be great for new construction. Can this be done in a cost-effective manner in existing facilities? And I'll let you weigh in on that, Steve.
Yeah, absolutely. So Eric's right. This does appear to be a great solution for new construction. That's really the best fit for it. But it doesn't mean that it can't be a fit for someone that wants to put DAS connectivity within inside their building today. We would ask those customers and ask them a couple of questions about future plans to upgrade other infrastructure. Perhaps they're looking at doing a Wi-Fi upgrade, a year or two down the road. Maybe the security camera system needs to be updated. Maybe they're looking for ways to change out or upgrade their existing, HVAC or lighting control sensors. So we would ask them about those kind of things and other plans for technology enhancement down the road, because they can lay out the infrastructure now today with the fiber optic cabling and kind of prepare for those upgrades down the road. They won't recognize those cost savings right away, but as they add those other applications down the road and don't have to, change or add new infrastructure from a cabling perspective, that's where they'll recognize those savings. So yes, it can be done in a cost-effective manner in existing facilities. We even have customers in a healthcare environment even looking at this solution for the space savings that it provides. A lot of times they're finding that in some of the older hospitals and older healthcare facilities that are out there, that their closets are already full. There's no room to put additional equipment. And this solution from a space savings perspective as well is very attractive to them.
Great. Thank you. And I want to let the folks know that are online that if you're considering in your facility to do an upgrade in any one of these type of networks, if you're considering an upgrade for Wi-Fi, or you're considering an upgrade to your traditional IP network infrastructure where you need to upgrade cabling, or if you're considering adding additional cellular services, or you want to improve the cellular connectivity inside your building, if you're going to do any one of those, if you'll contact us, we'd like to have a conversation with you about the advantages associated with doing that all at once with a total mobility type strategy, as opposed to thinking about each one of these networks disparately, to keep us from tearing up the ceiling more than once. If we have a long-term strategy for connectivity, and we can enable that with single-mode fiber down the hallways and close to the patient rooms and close to the facilities where connectivity is required, we can save an awful lot of money in terms of continued construction throughout the facility over the life of the building. And we know the cost associated every time that you break that ceiling membrane, the cost associated with that. And if we can prevent some of that from occurring, there's definitely cost savings. So we'd love to talk to you about that. We're running out of time here. We're bumping up against an hour, and our promise to you is we would only spend 40 minutes. So I'm going to sign us off here. We have all your questions recorded. If we didn't get to your question, we will respond to it via email. Those people that ask for additional information, we'll send you links to that information via email so that you can click on it and get the information that you needed. There were a couple of people that asked for some specific information about passive optical networks, and we'll provide that to you as well. We appreciate your time with us today on our G2 Talk webinar this day. We look forward to you attending another webinar in the future. Again, the information's archived. You can always go up to graybar.com and get it at a later date. And if you're online and you're one of the first 50, you get a cup of coffee. Enjoy it on Graybar and on Corning. Thank you very much, Stephen, for your help today. Thanks all of you that attended, and we'll see you the next time on a G2 Talk webinar. Have a great day.